In the last video, we looked at a basic introduction to logarithms. In this video, we're going to look at the log laws. We're going to look at 3 different laws and then apply them to a range of different questions to simplify logs. The first one we're going to look at is the power law. We can say now, using base 10, if we have log of a to the power of n, we can write this as n multiplied by log a. So this is the power law. We can multiply it down by the power, and of course we can reverse that process. Later on in the video we will look at how this works, but for now I just want to write down this particular law. So an example of this could be if we have now, again using base 10, log of x to the power of 4. We could write this now as 4 log of x. So these now are ways in which we can use the power law. If we had, for example, 2 log of y, we could write this now as log of y squared. So that is reversing the process. Now if we just consider here, let's say for example here y was equal to 10. If I now put this in the left hand side, we're going to have 2 log now of 10. Remember, this is base 10. Log of 10 is going to be 1. What power is 10 raised by to get 10? The answer is 1, so this would be 2 lots of 1. If we looked now at this particular side, what we've got is log of y squared. Well, 10 squared is 100, and we can see on here log of 100. What power is 10 raised by to get 100? The answer is 2. And we can see now that using that power law will allow us to simplify logs, and we can work in either direction. So that's the first log law. The next one is the following. This is when we're adding logs. If we've got log a plus log b, we can write this now as the log of a multiplied by b, or log ab. If we go back to our rules of indices, if we had now a to the power of m multiplied by a to the power of n, we can write this now as a to the power of m plus n. So when we're working with indices, if the bases are the same, when we multiply, we add. Remember, the logarithm is the inverse function of the exponential. Therefore, when we're adding logarithms, we're going to multiply. So if you're ever stuck, just go back to the rules of indices. When you're multiplying with rules of indices, you add. When you're adding now with logs, you multiply. So that's that one just there. And we're also going to have now one more which we can use. Essentially these two are used in tandem as such. Log a minus log b. This becomes a quotient, or if you like, we have now division, and that is a over b. Again, if you struggle to remember this one, these two are far more intuitive than the one here, which we're going to look at later in the video. If we just think about it now, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. And we know that from our rules of indices. So when we're dividing, we subtract. When we subtract, we divide. So let's just look at these, for example. So if I had now on here, let's say I've got log of 2 plus now log of 6, then we could write this now as log of 2 multiplied by 6, and that would give me log 12. If I had now log, let's say, let's go for 8 minus log 2, we could write this now as log of 8 over 2, which of course would give us now log 4. Let's just write that there. So nice and straightforward. So they are the log laws. The power law, and then we look at the sum and the difference, or if you like, addition and subtraction laws. If you can remember this and you're struggling with these, just simply derive it now from the inverse of the exponential form. So let's go ahead and look at applying these. So if you've not got them written down, write them down, as we're going to go through a whole host of different examples of where we can use these. Initially, some of these look a complete nightmare, but with a bit of practice, they're okay. So We're asked to write the following in the form a multiplied by log to the base b of c. So what we've got here is log to the base b of c to the power of 4. All this is asking me to do now is use the power law to bring the 4 down. So in a, we could write this as 4 lots of log to the base b of c. And that now gives us the value of a. This is a. It's just now a multiple. In the same way, if we were given this particular expression and we wanted to write this as log to the base b of c to the power of n, we would simply bring the 4 back up and we'd write it now as log to the base b of c to the 4th. Okay, here we're going to bring this power back up and we need to go ahead and multiply. So we need it in this particular form. So just thinking about 3 times by 3 is 9. So I can bring that down and we can write this as 9 lots of log to the base b of c. That's what it wants. It wants this power bringing down. All I need to do is multiply. I did 4 times 1, so I do 3 times 3. In the same way, I could bring that back up if I wished. So in this particular case, a is going to be 9. Okay, this one right here. I'm going to rewrite this. And I'm just going to write this now as 5 log to the base b of c now to the power of negative 1. 1 over c is negative 1. Therefore, we're going to multiply down by the negative 1 and we get negative 5 log to the base b of c. So the value of a is going to be negative 5. The question wants c, not 1 over c. Okay, final one. Let's have a go at this one just here. We've got 0.25 log to the base b of root c. I'm going to first write now 0.25 as 1/4. I'm then going to rewrite log to the base b of c, the root of c, as c to the 1/2. Remember, the root of c is c to the 1/2. We're going to now write this in the form a log to the base b of c. We simply multiply down by the power. So we'll have now 1/8 log to the base b of c, or if you like, 0.125. I prefer to leave it now as a fraction. I've simply rewritten this as a fraction, and I've now converted the root to the half power. We know that root a in the rules of indices gives us now a to the half, so that's converting from surd to index form. Okay, question 7. Write the following in the form log to the base b of c to the power of a. So this time we're bringing this value back up. So we're reversing what we did. So the first one, all I need to do is multiply the 2 by the 5. So log to the base b of c to the power of 10. So a here, you might see this as n. I've just put it as a. N is perfectly fine. So that's what we're going to get. Let's just rewrite this one. 4 log to the base b. Now we've got the cube root of c. The cube root of c will give me c to the 1/3 power. So bringing the 4 back up and multiplying log to the base b of c to the power of 4/3. So the value of a is going to be 4/3. Right, let's do the next one. Again, with this one, we're going to simplify first. So we've got now negative 2 log to the base b of c to the power of negative 3. So multiplying the 2, we can write this as log to the base b of c to the power of positive 6. So positive 6. So the value now of a is positive 6. I'm just rewriting these. Okay, again, 2 decimals which you can write as fractions. So 0.75 is 3/4. Log to the base b of c to the power of 1/4. So we're going to bring this up and we can write this now as log to the base b of c, and multiplying these 2 fractions, that's going to give me 3/16. So the value of a is 3/16. So that's just using the power law. We can go forwards and go backwards with it. Should we just look at how the power law works? I think it's important. It's fairly intuitive how the addition and subtraction works, but the power law less so. So let's go back to now our exponential statement of a to the b is equal to c. If you don't want to watch this bit, skip forward. It's just I always think that it's important just to give some justification for this. So that is the exponential statement, and the equivalent logarithmic one would be log to the base a of c is equal to b. Remember, the logarithm is simply now the power the base is raised by to give a certain value. What I'm going to do now with this is just take this particular equation and raise each side of the equation to the power of d. So if I have that, I'll have a to the power of b raised to the power of d is equal to c to the power of d. If I just look at this now, I can write this as a to the power of bd. Remember, if we're raising to a power, we're going to multiply, and that will be equal to c to the power of d. So if I start here and rewrite the logarithmic statement here, we can say at this point now that log to the base a of c to the power of d is going to be equal now to this power right here, which is going to be b multiplied by d. So that's what we've got here. We've already got now an expression for b just here. So if I go ahead and just show why this works in terms of the quick manipulation, we've got now log to the base a of c to the power of d is equal to, and I'm going to simply put this in, we've got now d multiplied by log to the base a of c. So we can see from this now how, I suppose if you want to call that a proof, I suppose it is, how we get now the power law. We're simply now taking the either side of this equation to the power of, and I've just introduced d, it could have been anything, and we see now taking logs or rewriting the logarithmic statement will simply now allow us to write log to the base a of c to the power of d is equal to bd. We've got an expression for b here, so we can substitute that in. So that's how it works. As I say, it's less intuitive than the other two, but I think just adding that for completeness is again, highly unlikely that you'd need to be able to show that. Okay, let's now look at question 8. We're asked to rewrite the following as single logarithms. When we're talking about single logarithms, we're talking about the addition and subtraction laws. So right here, I've got log 2 plus log 3. So all I'm going to do is write this now as log, and I'm going to just show my workings initially as 2 multiplied by 3. If we're adding, we multiply now these two values, which is going to give us now log 6. So that now is a single logarithm. We got two different logarithms here, but now it's going to be log 6. Just out of interest, if we had now, let's put this here, log 2 plus log 5, we could write this as log of 2 times 5, which is 10. Log of 10 is going to give us now 1. So some will simplify quite nicely. Okay, log to the base b of a plus log to the base b of c squared. So we've got now the same base logarithm. So all I need to do now is go ahead and write this as log to the base b of a multiplied by c squared. So we can write this now as ac squared. If you want to bracket it off, perfectly fine. That now is using the log laws. Okay, with this one, what we need to do is write it as a single logarithm. We got the same base, which is b. I'm just going to bring the power up. We're not asking now for 2 and 1 of something. I need to bring this power up. So I'm going to rewrite this now as log to the base b of p squared plus log to the base b of 5c. So at this stage, all we need to do is, when we're adding, is multiply the p squared and the 5c. So I'm going to write this as log to the base b of 5c p squared. Just keeping that now in terms of the alphabetical order. So with this, I need to bring the power up. With this one, I need to bring the power up. So ideally, what we're looking for now is an expression, something like this, where we can just go ahead and multiply. Okay, next one, we've got now subtraction, so that's division. So this becomes log of 5 divided by 2. If you want to write 2.5, you can do. I prefer to work with fractions. Okay, this one here, we're just going to go ahead now and use the power law. So I'm going to write this now as log of 3 squared minus log of 2 to the power of 5. I'm going to write this now as log of 9 minus log of 2 to the power of 5, which is 32. Now we've got subtraction, so we'll have division. Log now of 9, and we can write this as 9 over 32. And that isn't going to simplify any further. When you're doing this, if you want to check it on a calculator, let's go ahead and do that. So what we'll have then on the first one, 2 log 3, and then we're going to subtract from that 5 log 2. So here is my base 10 button, as we can see. Remember as well, as discussed in the last video, we can't take the logarithm of a negative number to get a real value. So if I put in here negative 2, for example, it's not going to, it'll give me a math error. So let's just make that positive, which we should, and that's going to give me now that value right here. Now if I subtract from here log of 932, it should give me 9 over 32, it should give me 0. So 9 divided by 32, and that gives us 0, so we can see that that is correct. Okay, let's have a look at the next one. Right, this one just here, we need to write this as a single logarithm. I need to bring the power up. I can't have 3 lots of something and 2 lots of something. Bases are the same, so I'm just going to write this now as log to the base b of p to the power of 3 minus log to the base b of r squared. I've now got log to the base b and log to the base b. We've got subtraction, so that's going to be division. Log to the base b of p cubed over r squared. And if you want, you can write it like so. So that's nice and straightforward. Okay, this one just here. Lots of different approaches. 9 is a power of 3. We could just write this now, if you want, as log. Remember, this is base 10, log 3 plus, and if you want, you can write this now as log of 3 to the negative 1, entirely, 3 to the negative 2, entirely up to you. So that's going to give us now log, and then we're going to multiply these, and that's going to give me now 3 to the negative 1, or if you like, 1 over 3. Alternatively, you could have just gone ahead and said if log now 3 plus log 9, that's going to give us log now of 3 over 9, which we can write as log of 1/3. So depending on how your brain works, remember these two are equivalent statements, entirely up to you. Right, let's have a look at the next one. Okay, we've got now addition and subtraction. I'm going to do now the addition first, and I'm just going to rewrite each of these terms. Let's just write it first. Log of a squared plus log of b to the 5th minus now log of c to the 1/2. If I consider this part first, this is going to give me now log of a squared b to the 5th. All I'm doing here is now, if we're going to be adding, we multiply, minus log, and then we're going to have c to the 1/2. We're subtracting, so we're going to have division. So we'll have log of a squared b to the 5th divided now by c to the 1/2, and that is one of the many ways in which you can write that. Certainly don't have to do it like that. I prefer to write it like so and go from there. Okay, let's look at the next one. I'm just going to rewrite this. We've got here base 8, and it's consistent throughout. So what we've got then is 1/2 log to the base 8 of x. Now if I just look at this here, I've got now log to the base x to the 1/2. Now if I just write this here, it might be easier to see. Log to the base now 8 of x to the 1/2. And then this one right here, I've got now minus log to the base 8 of 3y. If I look here, I could bring that up. So I've got log to the base 8 of x to the power of 1/2 plus log to the base 8 of x to the power of 1/2. And then we're going to get minus log to the base 8 of 3y. If I've got the addition here, what we could say is that we got two lots of this and bring that power up, or we can just write that this is going to be log to the base 8 of now x to the 1/2 multiplied by x to the 1/2. I'm taking this slowly, step by step. I wouldn't necessarily do this in an exam, but it sort of gives you an idea of how you can simplify. So what we've got then is log to the base 8 of just x, remember, rules of indices, minus log to the base 8 of 3y, subtraction, log to the base 8 of x divided by 3y. And that now is what we wanted. With this, you could have said at this point, what I've got here is 2 log to the base 8 of x to the half, and brought the power up, which would just give you log to the base 8 of x to the power of 1. 2 times a half is 1, which is exactly what we've got here. So lots of different approaches, entirely up to you. I've done that step by step, so hopefully it's been, it's a bit slow, but it gives you an idea of what's happening. Okay, let's have a look at some others. So, in question 9, we're asked to express the following in the form log A plus log B. We've got powers here, so we'll assume that A and B, we can have P, we can have some power of P and some power of Q. All this is asking me to do is work this backwards. So if I just wrote the first one, what we've got now is log of P squared multiplied by Q. So I could write this now as log of P squared plus log of Q. We can work this backwards. If I ask you to now add these, we would multiply. Therefore, we can go backwards. So, for example, now we could say A is P squared, B is Q. Again, different questions will ask you different powers and so on and so forth. So, if we have now, let's say we've got a log to the base 2 now of, let's say we've got 8 P squared Q, and we wanted to write this now in some form like this. What we could write this now as is log to the base 2 of 8 plus log to the base 2 of P squared plus log to the base 2 of Q squared. So this gives us log to the base 2 of 8. What power is 2 raised by to get 8? So we could write this as 3 plus log to the base 2 of P squared plus log to the base 2 of Q squared. So you can see splitting it up, especially if we have a numeric value. It's quite nice to see that in action, that you can split that up. In the same way, it might ask you to write this as a single logarithm. And if it does, what we've got here, remember, is the power this base is raised by to give a certain value. So if you saw this, I would say to myself now, log to the base 2 of x is equal to 3. So 2 to the third power is what? And that could allow me to write it backwards. Again, that would be a more challenging question. Okay, let's look at this one. All we're going to do is split that up. So we're going to have log of 2 plus log of x cubed. You could write this again as log 2 plus 3 lots of log x. We're not asked for it in that particular form, but in other questions we might be. This one, now we've got division, so division is subtraction. So we're going to have log p minus log of r to the 4th. And again, we could write this as log p minus 4 lots of log r. Right, let's just deal with this one. What we're going to do now is write this as 3, and then we're going to have log p, and then we're going to have q to the power of 1/2. They want this in log a plus log b, so what I'm going to do is just bring the power up. So this is going to be log of p cubed, and then we're going to have q to the power of 3 over 2. So what I've done here is reversed the power law. If you consider now, we could write this as a log of p to the first q to the 1/2 raised to the third power. So that's what I get. 3 times by 1, 3 times by 1/2. So we could write this now as log of p cubed plus log of q to the power of 3 over 2. So that has left me now the coefficient in front of each of these being 1 as required rather than 3. Right, let's deal with this one. So we always have a messy one towards the end. So we've got now negative log, And in the numerator now, what we've got is the following. We've got p to the 1/4, that is the fourth root. And then we've got now q to the power of 0.4. I'm going to bring this power up, and we can write this now. If you just consider, if you brought the power up, that would be to the power of -1. And in an exam, I'd show that, but essentially all we need to do is invert the fraction. So this is what we're going to end up with. So I'll just show that. If we've got now p to the 1/4 over q to the 0.4, and we raise this to the -1, that's going to be p to the -1/4, which will go into the denominator, and then q, 1 over q to the -0.4 will come up into the numerator. So we've now got this scenario, brought the power up, rewritten it like so, and then we've just got a simple now division problem here, or if you like a quotient. So this now becomes the difference of logs. Log q 0.4 minus now log of p to the power of 1/4, and that is now writing in the form log a plus log b. So on there, that's what we've got. Now you could argue at this stage that I need to bring this up, and just looking at this again, probably I would suggest that I need to do this, just in terms of the plus and the minus. And I probably should, looking at any of these, this one here, I should probably in fact write this as log p plus log r to the -4th. Just looking again, this is slightly ambiguous in terms of what it's asking, but it's just asking me essentially to reverse the process of now the log laws. Okay, let's have a look at some others. Express the following in the form now a log x plus b log y. So this time we're going to split them up and bring the powers down. So if I look at this one now, I've got log of y squared x cubed. So I can write this as log of y squared plus log of x cubed. I'm just simply reversing now the addition law. Bringing the power down, I can write this as 2 log y plus, bringing the power down, 3 log x. So in this particular form, we could again just write it as 3 log x plus 2 log y. I've just gone ahead and split that up. Okay, let's look at this one right here. What we've got then is log of, and I'll just write this as x to the 1/2, and then we've got division, so this is going to be minus now log of y to the 5th. So if I've got now a quotient, or we've got two values divided, what we're going to do is just split that back up and write that as a difference. Bringing the power down, 1/2 log x minus, bringing the power down, 5 log y. And it's perfectly fine for me to write it as negative just there, because we can say that b is going to be now on here minus, it's a minus value, so it'll be -5. Right, let's look at this one. So what I'm just going to do is write this first, 3 log, and then what we've got is y to the power of 1/6 over now the cube root of x, which is going to be x to the 1/3. If I bring the power up, we can write this now as log of y to the 3 over 6, which is going to give me y to the power of 1/2. And bringing the power up, if we raise this to the 3rd power, that's just going to give me x to the power of 1. Therefore, we can split this up and we can write this as log of y to the 1/2 minus log x. So I can write this now in this particular form. We've got now negative log x plus 1/2 log y. So I've written it in the form that I want. Just remember, all we're doing now is reversing the power law. If we raise now y to the 1/6 to the power 3, 3 over 6, which is 1/2, and then 1/3 to the power 3, that's going to give us x to the 1st. Division, we split it up, and I've just rewritten it in the form that they asked for. Okay. In 11, we're asked to simplify the following. Log 8 plus log of 12.5. So what we'll have then is log, remember this is base 10 of 8 times by 12.5, 8 times by 12.5 is going to give me 100. Log of 100. What power is 10 raised by to get 100? The answer is 2. All log is, remember, log is just now log to the base 10. So right here we got log to the base 10 of 100. Okay, let's look at the next one. Log to base 5 of 100 minus log to base 5 of 4, which is going to give me 100 over 4. That gives me log to the base 5 of 25. What power is 5 raised by to get 25? Well, again, the answer is going to be 2. The answer is not always 2, it's just with these, it's nice and straightforward to work out. Right, log to the base 6 of 2 plus log to the base 6 of 108 plus 2 lots of log to the base 6 of 6. I'm just going to deal with this bit first. So what I'll have then is the first bit. If I have now log to the base 6 of 2 plus log to the base 6 of 108, this is going to give me log to the base 6 of 2 times by 108, which is 216. Okay, log to the base 6 of 216. What power is 6 raised by to get 216? And we can say that that is 3. If you want to check it on a calculator, 6 to the power of 3 is going to give us the 216. So that is 3. I've then got this right here. What we've got now is we're going to add to this 2 log to the base 6 of 6. Remember, log to the base a of a always gives us 1. We saw also that log base a to the power of 1 gave us 0. So all I'm going to do is use these properties. This is going to be equal on here now to 2 lots of 1, which is going to give me 2. So what we've got then are these two values. We need to add them, and of course we're going to end up with 5. You don't have to do it like that. You could have simply brought the power up and multiplied them all. So what you could have said with that one is log to the base 6 of 2 multiplied now by 108 multiplied by 6 squared, which is going to give us now 36. As you can see though, that is going to be a little messy. If you think about this right here, now if we did go ahead, 2 times by the 108 times by the 36, that's going to give us 7776. And if we went ahead and did log to the base 6 of this answer, we're going to get 5. But those numbers are messy, and that's why I split that one up. So I dealt with that. In terms of the workings, hopefully you've seen how I've done it, but you wouldn't necessarily have to do it like so. Okay, let's look at the next one. 2 log to the base 6 of 2 plus log to the base 6 of 9. So I'm going to write this now, and I'll do it step by step. Log to the base 6 of 2 squared plus log to the base 6 of 9. This is going to give me log to the base 6 of 4 times by 9. That's going to give me log to the base 6 now of 36. And we can see again, this is going to give me now log to base 6 of 36. What power is 6 raised by to give 36? Well, the answer is 2. Right, let's look at the last one here. In fact, we'll have to do it here. Right, this one right here. What we've got here is log to the base 2. And I'm going to just focus on this bit first. I can write this as a numeric value. I know 80 isn't a power of 2, 5 isn't a power of 2, but 32 is. So I'm just going to leave that alone for now, and I'm just going to bracket this bit off and deal with that. Let's just deal with this. So what we've got then is log to the base 2 of 80. We've got now subtraction, so I'm going to divide by the 5. That's going to give me now log to the base 2 of 80 over 5. 80 over 5 is going to give me 16. Log to the base 2 of 16. What power is 2 raised by to get 16? The answer is 4. So that's what we got. Again, if you want to check that in a calculator, if you do log to the base 2 of 80, this will generally be a non-calculator exercise, but again, if you're just practicing, and then we're going to subtract from that log to the base 2 of 5, this should now show us exactly what we expected, that we get the value now of 4. So that's that bit done. Okay, let's look at this one right here. What we've got now is 3 lots of log to the base 2 of 32. 2 to the power 5 is 32, so that's just going to be 5. I've got 3 lots, log to base 2 of 32, 5, which is going to be 15. So all we'll do is take now the 15 plus a 4, and that's going to give us now 19. Clearly not the way you would do it in your workings, but hopefully you can see what I've done. That corresponds to that, that corresponds to that, and then I've just put it back together. The reason why I wouldn't combine all of these is you're going to have 3 to the power of 32. You could work in powers of 2 to simplify it. I personally wouldn't. So for example, now we would have log to the base 2 of 16 plus now log to the base 2 of 32 cubed. Which again, if you want, you could write this as log to the base 2 of 2 to the 4th plus log to the base 2 of now 5 here. What we're going to have here, this is going to be 5 to the power 3, which is going to be 15. 2 to the power of 15, let's write that there. So this is going to be 4 log to the base 2 of 2 plus 15 log to the base 2 of 2, which is going to give 4 plus 15. So remember, these are just 1. So 4 lots of 1 plus 15 lots of 1. That's another way of doing it. I personally wouldn't do it like that as powers of 2. Loads of different ways. I'm leaving that open for you. Right. Given that log to the base 2 of p is equal to a and log to the base 2 of q is equal to b, simplify the following, giving your answers in terms of a and b. Okay, right, let's go ahead with this one. Let's split this one up. So what we've got then is log to the base 2 of p plus log to the base 2 of q squared. I already know that this is going to be a. Log to the base 2 of p is a. And I'm just going to write this, bringing the power down, to log to the base 2 of q. We know that log to the base 2 of q is b, so we could write this now as a plus 2b. So that now is in terms of a and b. So all I've done is split those up, brought the power down, and then I've tried to find an expression for now log or a in terms of log to the base 2 of p and b in terms of log to the base 2 of q. Okay, let's look at this one. This one now is going to be log to the base 2 of 8p minus log to the base 2 of q. I'm just going to rewrite this now as log to the base 2 of 8 plus, we've got 8 times by p, log to the base 2 of p minus log to the base 2 of q. Log to the base 2 of 8 is a numeric value. What power is 2 raised by to get 8? The answer is 3. We know that this is an expression here that will give us a, so we'll put 3 plus a. And this one is going to give us b, so it's 3 plus a minus b. So that is an expression in terms of a and b. Yes, we've got that constant there, but that's entirely perfect to write it in that particular form. Just split that 8p up as log to the base 2 of 8 plus log to the base 2 of p. That's just standard log laws. Okay, let's look at this last one. We got 1/2, and let's just write this here. We've got now 1/2, and I'm going to write this now as log to the base 2, and I'm just going to write this as 32p cubed q to the 4th. And remember, this is to the power of 1/2. It's the square root. I'm going to bring this down. You don't have to. It's entirely up to you. If I do, I'm going to get 1/4, and then I'm going to have the following. I'm going to have in here, all I've done is use the power law to bring this down, and I'm going to split this up. Log to the base 2 of 32 plus log to the base 2 of p cubed plus now log to the base 2 of q to the 4th. Okay, so just rewriting this, we got 1/4, that's on the outside, This is going to give me 5. What power is 2 raised by to get 32? The answer is 5. Plus, bringing the power down, 3 log to the base 2 of p. Bringing the power down, plus 4 log to the base 2 of q. This then is going to give me 1/4 of 5 plus 3a plus 4b. So if you wanted to write it like so and leave that quarter out, you could do. Otherwise, 5 over 4 plus 3 over 4a plus now b. And that's what we would end up getting. Entirely up to you. Again, can be done different ways. You could bring the half up and write this now as the quarter power. I prefer to bring it down, and that's what we would end up with. So there we go. That is now just working backwards and using the laws that we know. So there we go. A tutorial on the 3 laws. The power law, we've looked at then addition and subtraction of logs. We've gone through a whole host of examples. In later videos, we'll do exam questions where we've got some nasty problems that we need to simplify. But for now, that should get you started on log laws.